Welcome to Dependency Injection in Drupal 8. My name's Kat Bailey. I've been working with Drupal since 2007. And I got involved in core development a little over a year ago. And since then, I've been helping out a little with the Whiskey initiative, the Web Services and Context Core initiative. That's the initiative that's been mostly responsible for getting a lot of the Symfony components into Drupal core. Okay. So just a couple of things before I get started. I will be assuming a rudimentary understanding of object-oriented programming, as in I'll assume you know what I'm talking about when I'm talking about things like classes and interfaces and constructors. But you know, if the only experience you've had with object-oriented programming is maybe writing custom views handlers or something like that, that's totally fine. The examples will be very simplistic. The other thing I wanted to say is you've probably been hearing about the huge changes in Drupal 8 that are like just so fundamental and just bigger in nature than the kinds of changes you'll have seen between other versions of Drupal. But what I would say is that one of the major drives with the kinds of changes we've been making is towards more standard ways of doing things and getting away from Drupalisms. And certainly with dependency injection, you'll have to learn it for Drupal 8, but that's going to stand to you no matter, wherever your programming career takes you beyond Drupal 8. So what I'm going to cover, I'm going to start by looking at dependency injection as a design pattern, as a way of structuring classes. Then move on to looking at how frameworks support dependency injection, before getting more specific and looking at Symfony-style dependency injection, and then looking at what we're actually doing in Drupal. So the first item there, dependency injection as a design pattern, that's all about why, as in why should you care about dependency injection and what problems does it solve for us? And the rest of it then is all about how, like how do frameworks support this? So why dependency injection? Well, normally when the topic of dependency injection is introduced, you'd start off with an example of some object-oriented code which isn't doing dependency injection and look at the kinds of problems that can arise. But I thought it made more sense to take a bit of a step back, seeing as we're not all object-oriented programmers here, and just think about what sorts of common goals we might have when we're writing code. So I think we can probably all agree that when we write code, we want it to be clutter-free, reusable, and testable. Now, what I mean by clutter-free is just, when you're writing a function, you want it to be to the point and not going off on tangents. You don't want to have lines of code that aren't central to what that function is all about. And we'll see some examples of this in a moment. Reusable, obviously, when you go to the trouble of writing a function to do something awesome, you want to be able to use it over and over again in different contexts. And very closely tied to that, probably the first context you want to use it in is within the context of a test. We want to be able to test the code we write. So we'll start by looking at an example of some procedural code that kind of does it wrong. This is a totally contrived example. It's a very silly function that doesn't do anything interesting, but if you see the first line of the function body there, loads an include file from a module because it knows that it's going to have to, that's where the function is that it calls on the next line. That module load include, that's an example of clutter. Like it happens to be necessary clutter, but this function isn't in the business of loading files. So that's clutter. As for reusability, obviously this can't be reused outside of the context of a bootstrapped Drupal, and it's very closely tied to whatever this other module does for it. So it's not great, it's not clutter-free, it's not easily reusable, and it's not easily testable. Like if you wanted to test this function, you'd either have to have a bootstrapped Drupal or at least load the file where module load include is defined. So let's now look at the sort of classic example of doing it wrong in object-oriented code. Again, a fairly contrived example. This is a notifier class that we have, and its main sort of thing that it does is the notify method, which during the course of whatever it does, it sends an email. And it uses an emailer object to send that email. And how it gets that, you see in its constructor, it instantiates one for itself. At first glance, it doesn't look like there's an awful lot of clutter going on here, but that line where it's instantiating a mailer object, that new mailer, we could see that as clutter, because this class should not be in the business of loading and knowing how to instantiate a mailer object. Because, what if it's not that simple? Maybe the mailer actually takes various parameters. And if those parameters change, like if anything about the mailer class changes, well, then this class is going to have to change accordingly. So we say that it's tightly coupled to the mailer class, and that's bad. In terms of reusability then, what if you didn't want to use the mailer class as the class that sends the email, you wanted to use something else. And then obviously testability, right? You'd prefer to use a mock mailer, something that's not actually going to send an email. But here we don't have a choice. We're being forced, it's going to instantiate a mailer object whether we like it or not. So what can we do about it? The only difference here, you'll see, rather than instantiating a mailer in its constructor, it takes one as its constructor parameter. And so now it doesn't need to know how to instantiate the mailer. Now it's worth just transitioning back and seeing the difference between that, instantiating the thing in its constructor, and that, receiving it as a constructor parameter. That's dependency injection, all right? That's all it is. So like as one guy put it in a blog post I read recently, dependency injection is a $25 term for a 5-cent concept. Like you're just passing the object its instance variables as constructor parameters, or if you want to be really fancy about it, you're injecting it with its dependencies. So here I've just put the calling code at the bottom, so the thing that's going to instantiate the notifier, first it's going to instantiate a mailer object, and then it passes that into the constructor. So if we reframe this in terms of the goals that we had about writing code that's clutter-free, reusable, and testable, another way of thinking about that is we want to write code that's ignorant. Why ignorant? So the less your code knows, the more reusable it is. And if you think about it, the more your code knows, like the more it knows about other classes and how to instantiate those classes, the more dependent it is that that knowledge that it has stays the same. And that's that tight coupling that we want to get away from. So let's look at this again and think, well, what does the notifier class really need to know about the thing that it's going to use to send the email? Does it even need to know what the concrete class is that gets injected into it? It doesn't. All it needs to know is that it's going to get a thing on which it can call the send method and pass these parameters. And so the way we express that is it'll accept anything that implements the mailer interface. So now at the bottom you can see, instead of instantiating a mailer object, we use a special mailer and pass that in instead. So that is constructor injection, one form of dependency injection. So the calling code at the bottom is injecting the mailer into the notifier, and you can see the constructor at the top is expressing its dependency on anything that implements the mailer interface. So dependency injection is about declaratively expressing dependencies in the class definition rather than instantiating them in the class itself. So it's about having classes that are just kind of saying, like, I need these things to do my job, so you're going to have to call me with my dependencies if you want me to do anything. Constructor injection is not the only form of dependency injection. It's the most common, and it's certainly by far the most common that we use in Drupal, but there are some other forms. Another common form is setter injection. So with setter injection, rather than injecting things in the constructor, here we have a setter method, setMailer, that again accepts anything that implements the mailer interface. And so your calling code, after instantiating the object, will need to call the setMailer method and pass in the dependency. So that's setter injection. There's also interface injection, which is very similar to setter injection. It's just that for every setter method that you have for a dependency, there's an interface for that. So it's like the class basically declares itself as being mailer injectable, for example. It's very verbose because for every setter method you need to have an interface, and it's not very common. I don't think there are any frameworks that actually support interface injection. You'll often hear dependency injection referred to as inversion of control. These two terms are synonymous, and I don't know about you, but when I first heard that, it wasn't immediately clear to me why it was called inversion of control. I mean, I saw there was some kind of inversion going on, but it wasn't crystal clear until I read one particular explanation of it, which I've illustrated here. So traditionally, you might have a library of classes that your code makes use of. So your code is going to call out and instantiate objects from that library of classes. And in this setup, the library is passive. It's just kind of sitting there going, here's some classes that you can use if you like. And your code is the active party. It's actively calling out and instantiating objects from those classes. But with dependency injection, the framework is the active party, and it's going to call your code with its dependencies. So again, your code this time now is passive and saying, like, I need to be called with my dependencies if I'm going to do my job. So that's the sense in which control is inverted here. And inversion of control is often referred to as the Hollywood principle, because as they say in Hollywood, don't call us, we'll call you. Now, that, if you take away nothing else from this talk, apart from what I've covered so far, which I hope won't be the case, but if it is, it's not the end of the world, because that really is the most important part. Like, that's why we care about dependency injection. We've created this class that's decoupled, it's clutter-free, it's reusable, and it's really easy to test. And the rest of the talk is about how frameworks support that, but obviously the how is completely irrelevant if you don't understand the why. So now we have our classes all nicely decoupled from each other, declaratively expressing their dependencies. The question arises, I mean, I've put that calling code down there at the bottom, but where does that go, all right? In other words, where does injection actually happen? So the first option is the most obvious, like manual injection, which is just like the code that we just saw, the calling code that actually instantiated the mailer and injected it into the notifier. But does that belong in a class somewhere? Then that class is responsible for knowing how to instantiate the dependencies for the notifier, etc. And you can imagine in the context of a framework where you want to support different implementations for dependencies, etc. So that doesn't really work very well. Another option is to use a factory. A factory is just a class that's responsible for instantiating objects of a particular kind. But you'd end up either needing a separate factory class or needing a bunch of logic to deal with every possible object graph you could possibly want to instantiate. And by object graph, I just mean different concrete implementations, like for the dependencies and the dependencies of the dependencies, etc. So what frameworks do to support dependency injection is they use what's called a container or an injector. Actually, it goes by various names. So dependency injector or a dependency injection container, also known by its charming acronym, which in fairness is the easiest way to refer to it. The shortest way to refer to it, anyway. Or it's also called an IOC container for inversion of control, or a service container, and I'll explain why service container in a moment. But basically, what it does, it assumes responsibility for constructing your object graphs, so instantiating your classes with their dependencies. It uses configuration data to know how to do this, and it allows infrastructure logic to be kept separate from application logic. So why this word services? So you need to forget about web services or services module for a moment. A service is just an object that provides some kind of globally useful functionality. That's best explained with an example. So here's some examples of services. A cache backend, for example. You can imagine using a cache backend in your own code where you want to say, get me something from the cache. Or similarly with a logger, you would use a logger to just log stuff, and you don't want to know anything about how a logger works, you just want to use it. A mailer, obviously, as we've seen, and a URL generator is another example. Here are some things that are definitely not services. These are data objects, right? A product, a blog post, an email message. So that should give you some idea of what we're talking about when we're talking about services, and we're not talking about data objects like this. So I found this nice diagram in a book on dependency injection, which I think gives a nice kind of simple overview of how things work together. But I've added my own personal touch to it, because basically there are three things you need to be aware of when you're working with a dependency injection container. The first is classes, and by that I'm just referring to what we've already talked about. This is the fact that you have all your classes are nicely decoupled from each other, and they're just declaratively expressing their dependencies. But the classes don't know anything about the container. They don't know that they're going to be instantiated by a container. They're just regular classes. Then there's configuration, which gets fed into the container. And the configuration consists of service definitions, all right? So for each service has an identifier, and then the definition consists of, or specifies which class to instantiate for that service and what its dependencies are. And so the dependencies will then be references to other services. So you can imagine when the injector or the container gets asked for a particular service, that it's going to look up what class to instantiate. It's going to see if it has dependencies. If it has dependencies, it'll go and instantiate those first, but they might have dependencies as well, et cetera, et cetera. So you can imagine there's this kind of viral injection that happens once a particular service is requested. And then the third piece of the puzzle is understanding the application flow. Like, how does the application even interact with the container? Because obviously, the regular code we write isn't going to know about the container at all, and it shouldn't. But at some point, like at the entry point to the application, there's going to have to be, first of all, it's going to have to instantiate this container thing, and it's going to have to ask it for services. So understanding how that flow works is important too. So once you have your classes all loosely coupled and declaratively expressing their dependencies, the rest of it is all about getting wired in. You talk about getting wired into the container. So I'm just showing some example configuration. Most frameworks support XML-based configuration. This is a kind of made-up sample. It's loosely based on a Java framework called Spring. And so here we're just specifying where we've got 3 services. Each of them has an ID. And you can see 2 of them have constructor arguments that reference other services. So you can imagine, you'd have a huge, big, long list of these services, each with an ID, and they could be referencing other services and basically saying, I need that other service in order to do my thing. So this is pretty typical of an XML-based configuration for a dependency injection container. So how it works, again, service keys map to service definitions. The definitions specify which class to instantiate and what its dependencies are. And then those dependencies are specified as references to other services using their keys. And at the end of the day, the container is an object, right? So there'll be some method that needs to be called on it to ask it for a particular service by passing in the key. Scope is something that's used. This idea is common to most dependency injection frameworks. And scope just refers to the context under which the service key refers to the same instance. So for example, each time a request is made for a particular service, should it instantiate a new object each time, or should it always give you the same instance? And different frameworks have different default scopes, as we'll see shortly. So Symfony has a dependency injection component. This is a standalone component that can be used in various frameworks. So it's used in the Symfony full stack framework, and it's used in Drupal 8. And what the component is a bunch of classes, including the container class itself, and then various supporting classes for like loading configuration and all that stuff. A couple of things to note about how Symfony does dependency injection. It uses string keys, which is fairly typical, but there are other ways of identifying services. This is just this is a very simple way of, you can just use an arbitrary string. Obviously, most frameworks will have some kind of naming convention for how to name services. And then, in addition to being able to specify the class for a particular service and what its dependencies are, you can also specify additional methods to be called on the object once it has been instantiated. And that comes in pretty handy, as we'll see shortly. In Symfony, the default scope is container scope, meaning for the lifetime of the container, unless you specify otherwise when you're defining a service, then for the lifetime of the container, the same instance will be returned each time that service is requested. So if you wanted it to be a new instance each time, you'd have to specify prototype scope. It can be configured in PHP via an API, where you just make API calls to register services to the container, or you can use XML, similar to what we saw, and you can also use YAML. And the container can be compiled down to plain PHP. And in order to understand what the hell that's all about, we need to look into some Symfony terminology. Now, I almost feel I need to apologize for this part of the talk because, I was saying we're getting rid of Drupalisms, yay, but now you have to learn all these Symfonyisms. But the good news is, most of the code you write, the regular code that you write in your lovely decoupled classes, won't need to know anything about Symfony or Symfonyisms at all. This is just for understanding how your classes can get wired into the container. So, what's this compiling business? Well, you can imagine that if we're parsing these configuration files to find out about service definitions, it's going to be if you've got a lot of services, it's going to be really expensive to do that on every request. So Symfony allows us to parse it once, or parse when necessary, as in whenever that configuration changes, and then dump out the result of that into a PHP class. So it actually writes out a PHP class, hard-coding a method for each service definition, or for each service. And what that looks like, so this would be the class that actually got written out by Symfony during its compiling phase. And in this case, it obviously only found one service, and it was the example service. So it wrote a method for that called getExampleService, and what that'll do is it'll just return a new instance of some class. So that's what the compiled container looks like. Synthetic services, these are just services that the container doesn't actually know how to instantiate itself. But if something gets instantiated outside of the container can still be told about it. So if anything else expresses a dependency on that thing, it knows it can just pass this object to it. Compiler passes. This is all about modifying existing definitions of services. So compiler passes are classes that you can use to process the container and change what's in there. So an obvious use case would be if you want to actually change the class that gets instantiated for a given service. Say you had the cache backend service or something, and the default one used a database, and you wanted to switch it out and make sure it uses the one that had a memcache or whatever. You could just change the class that was used. And then another common use is what are called tagged services. Now, what are they? So tagging, you can just add arbitrary tags when you define your services, and all that is it's just some way that you can then flag certain services for some kind of processing, which you do in a compiler pass. And this is used, for example, to register event subscribers to Symfony's event dispatcher. Bundles. I mention these reluctantly for obvious reasons. We already have a type of bundle in core, and now we have this other one. Basically, bundles are Symfony's answer to plugins or modules, prepackaged sets of functionality implementing a particular feature. And each bundle includes a class implementing the bundle interface, which allows it to interact with the container, for example, to add compiler passes. Now, the only reason I mention it at all is because we kind of use Symfony's bundle idea in core just for the ability to allow third-party extensions, i.e. modules, to provide that class that can then interact with the container and modify existing services. Now, it's worth going off on a little bit of a tangent to look at the event dispatcher. This is actually a separate component. It's not part of the dependency injection component in Symfony. It's a separate Symfony component, and we use it in Drupal core. And the reason it's worth looking at is not only because it's a good illustration of all that stuff about compiler passes and tagging, but it also plays a very important role in the application flow. So if you remember that diagram with the three things, of how everything ties in together. So understanding the application flow and how the application interacts with the container, the event dispatcher plays a very key role there. So what it is, I mean, it's a very similar mechanism to, it's an alternative to Drupal's hooks system. So this dispatcher dispatches events. Those could be events around the handling of a request. But it can be used to dispatch any kind of custom event you want to make up. Event listeners are registered to the dispatcher, so it then notifies them when a particular event takes place. And then event subscribers those are just classes that provide a whole bunch of listeners. So each listener is a method in this event subscriber class. And it basically is able to tell the dispatcher that for certain events, these are its listeners. So a compiler pass is used to do that, to register all event subscribers to the dispatcher using their service IDs. And it does that using tagging. It tags them. You tag a service as an event subscriber, and that means during this compiler pass process, it'll get added to the dispatcher. And the dispatcher actually holds a reference to the container, which means if it's given service IDs, it can get those services from the container. So it can instantiate these subscriber services with their dependencies. Now, I have that in inverted commas because when you think about it, event subscribers, they're not really services in the strict sense. They're not like what I defined earlier as objects that provide some kind of globally useful functionality. They're not going to be used by something else. But they're services purely in the sense that they are wired directly into the container. And that's just all key in that sort of application flow and how things get kicked off in terms of that sort of viral injection of dependencies. Okay, so this and the next slide are as nitty-gritty as it's going to get, I promise. Just showing you what this is actually Drupal 8 code. This is that compiler pass class where the event subscribers get registered to the dispatcher. So the class implements the compiler pass interface, which is just that one method for processing the container and doing whatever modifications you want to do. So in this case, we want to modify the event dispatcher. And the way we're modifying it is we're basically specifying that for every service that has been defined with the event subscriber tag, we need the container to call a particular method on the dispatcher after instantiating it. And so it's going to call the add subscriber service method. So that's an example of this, the fact that Symfony lets you specify additional methods to call after instantiating a service. And that's how it's used. And how the actual compiler pass gets registered or gets added to the container is using this bundle mechanism. So we have this core bundle, which we use to add compiler passes for various things. So now that we've seen some actual Drupal code, it's time to talk about dependency injection in Drupal 8. So Drupal 8 has a dependency injection container, obviously. It provides a whole bunch of services. Some common ones that you will definitely be using, the default database connection is a service. There's a service called the module handler, which you'll need that if you want to invoke hooks in other modules or do anything that requires knowledge of enabled modules. The HTTP request object is also a service, but that's an example of a synthetic service, right? That doesn't actually get instantiated by the container. It gets, the container just gets told about it so that other things can depend on the request service. This is a bit of a wall of text. I just wanted to show an example of the configuration for the container in Drupal. So we use YAML. And this is just an extract from the core.services.yaml file where all of core's services are defined. If you skip down to the last one, path.aliasManager, and just so we specify what class to instantiate for the alias manager and then what its dependencies are. So these are just the constructor arguments to pass, and each one of those is a reference to one of the previous services. The @ symbol is just how we tell the container this thing is a reference to an existing service. So it'll know then to instantiate those other services first before instantiating the alias manager. And I just wanted to show, this is alias manager's constructor. I'm showing it just to kind of point out that like the alias manager itself doesn't know anything about the container. It's just saying like it needs a database connection, it needs something called an alias whitelist, and something else called a language manager, and as long as it gets those things, it's happy. So if you want to use any of the services provided by core, you've got a couple of options. The first is if you're stuck in the land of procedural code, you can use a helper. So it's a static method on the Drupal class where you just ask for some service, specifying it by its key. That's not the preferred method. That's essentially a kind of an anti-pattern known as service locator, where you know about the container, and so that means in order to be able to do anything with it, you need to know the names of actual services. And we don't want our code to know the names of actual services, right? That ties our code to the container itself, and we want to get away from that. So the preferred option is to write object-oriented code and get wired into the container. Now, this diagram quite possibly breaks all kinds of rules in terms of diagrams. It was just my attempt to somehow get across in as simplistic a way as possible what the actual application flow is in Drupal, like how does the container get instantiated, etc. So basically what happens is index.php instantiates this thing called the Drupal kernel and asks it to handle a request. The Drupal kernel doesn't actually know how to handle a request, but it knows how to build, how to construct the dependency injection container. So it does that, and that's, on a regular page request, that's going to be just instantiating that, that hard-coded class that we saw where everything has, so it's just a class that has a bunch of methods that know how to return objects for services. So once it has instantiated the container, it asks it for a thing called the HTTP kernel service, because the HTTP kernel is what knows how to handle a request. So it gets that from the container and then passes off handling of the request. And the HTTP kernel has a couple of dependencies. One of them is our friend, the event dispatcher, and the other is a thing called a controller resolver. So with the event dispatcher, as we already saw, it already knows what all of the listeners are that listen to particular events. So when the request is being handled, one of the first things that happens is the dispatcher dispatches the request event, basically just saying, does anything out there want to react to the fact that this request has come in? Maybe make some changes to the request itself. So obviously one way that things get hooked in is as these event subscriber services, and they will get instantiated with their dependencies by the dispatcher itself. And then the other way, and probably the more common way that you will end up interacting with the container, is code for a particular page. So with Symfony, we don't have page callbacks anymore. We have the equivalent, which is we have this new routing system which matches a path to a route which specifies a controller, and the controller is just the actual page callback for that particular path. So the controller resolver's job is just to find what the controller is for that route. And so in a moment we'll see how you can get hooked in, how your controller can get hooked in, and why I have a question mark around whether it should be a service. But first, just a quick look at how you would get wired in as an event subscriber. First thing is you need to implement the event subscriber interface. There's just one method in this interface, which is a static method where you're basically telling the dispatcher what events you want to listen to. So in this case, it's saying it wants to listen to the request event, and the method that should fire on that event is the onKernel request method, which refers to one of its own methods, and that method will be called in that event. So that's the interface that needs to be implemented to hook in. And then the other thing is that it will need to get defined as a service, and the service will need to be tagged as an event subscriber. And so one example of this is, for example, the path subscriber, which is responsible for resolving the request path to a system path. So it subscribes to the request event, looks at one of the attributes of the request, and then it has a dependency on the alias manager to look that up and convert it to a system path. But as I said, you're more likely to be interested in getting hooked in for code that should run on a particular page. So how do you get your controller wired in? So controllers obviously are going to have dependencies on services, like the database and various other things. But whether they should themselves be directly wired into the container is quite a hotly debated topic in the Symfony community. So like the core Symfony guys are against the idea of controllers themselves being services, whereas the Symfony CMF guys, it's another framework built on top of Symfony components, they think controllers should be services. In Drupal, our feeling was that they should not be. I mean, one main reason is when you think about it, you're going to have an awful lot of controllers, right? Controllers are your page callbacks. And if every single one of those is a service, you're going to have your service container is just going to be a huge, big, bloated thing full of services that are really just for glue code, because your controller should really just be about matching the route to the code that needs to run. So I think it's supported. Your controllers can be wired in directly as services, but it's not the recommended way. The recommended way is to implement an interface. It's the controller interface, I believe, and it's just one method, a static factory method, and that factory method accepts the entire container and can use it then to pull out services and instantiate the controller with whatever services it needs. An excellent example of this in core is book module, so have a look at that. And there's also really great documentation explaining how book module was converted to use the new routing system and how book module's controller gets its dependencies injected. First rule of dependency injection containers: don't inject the container ever, unless you absolutely must. And so the thinking behind that is basically once you inject the container into one of your classes is then coupled to the container. The only way it can do anything with it is if it knows about service IDs. And why would you want your class to have that kind of knowledge? So the only time you'd ever have a class that has the container as a dependency is if that is just part of your infrastructure logic. So not your normal code for that does the regular stuff, just the code that is part of the framework itself, really. For those curious who want to actually dive in and look in the Drupal 8 code base and see where all this is happening, so I've just listed where you can find this stuff. So where the Drupal kernel is, where the services are defined, where this bundle thing is, which may not always be called a bundle. We may get to change that in time. We'll see. Because it's, as I said, it's just about allowing modules to modify the container in some respect. And then where the compiler passes are. Core has a number of compiler passes, including the one for registering event subscribers. And then for your modules, if you want to write some nice decoupled classes and have them wired into the container, if you want to define them as services, you'll have a YAML file for them. And then you'll need, if you want to use that compiler path mechanism, you'll need a bundle class as well for your module. And all classes, including compiler path classes, need to live in a particular directory. Now that's just tied into our the PSR0 standard that we're using for namespacing classes, so that our autoloader knows where to find them. So that's basically all I wanted to show you about dependency injection, but I wanted to finish off really quick just to talk about testability, because we now have PHP unit in core, which is a really awesome unit testing framework. And so that, in conjunction with using dependency injection, makes for really easy testability. Now, this has nothing to do with the container at all, so you can forget about that for this. This is just about having lovely decoupled classes and a lovely testing framework to test them with. So there's just one thing I wanted to cover with it, which is the ability to create test doubles or stubs. So say one of your classes has a dependency on something. The language manager is a good example because it's a bit of a gnarly one. I think it still calls out to procedural functions. And if anyone was in Mark Sonnebaum's talk earlier this morning about, we can't have that kind of thing, those kinds of hidden dependencies in unit tests, because these procedural functions probably end up calling out to looking for database connections, and all kind of horrible things can happen. So we don't want to instantiate the actual language manager. We're just trying to test a class that has a dependency on the language manager. So instead, we can create a stub of it, and PHP unit provides these helper methods for creating these. So the getMock method, you just tell it what class.
Move your microphone.
Is it safe?
Move closer to it.
That would be helpful.
Move closer to it?
Yeah, tilt it down towards your mouth.
Okay. Is that all right now?
Closer.
How's that? Is it even on? I don't think it's, oh.
There we go.
How's that? Okay. Right, so PHP unit allows us to create stubs of things just by specifying what the class is, and then you can just tell it what behavior you want it to exhibit when you're using it. The point here is we're not interested in testing the language manager class itself. We just know that the class we are testing needs a language manager, or needs something that it thinks is a language manager, and it's going to behave the way the language manager would behave. So we just tell it to behave in a certain way. And in this case, we're saying, if the getLanguage method gets called on this class, it should return this standard class object with these properties representing the English language. So that's a very straightforward use of this getMock method that's provided by PHP unit. Here's a slightly more complex one. If we wanted to mock the alias manager, so as we saw, the alias manager has a bunch of dependencies, one of which is the dependency, or which is the database connection, and then a couple of other things. But we just want to pass in an alias manager to the class that we're testing and know that it's going to behave the way it should. So we disable the original constructor when we're creating a mock for this. And below there, we're specifying how we want it to respond to the getSystemPath method call. And we're using a value map, and that allows us to say, if getSystemPath is called with the parameter foo, then return user/1. If it gets called with the parameter bar, then return node/1. So that makes for like really, really tests that are just a joy to write when you can use this stuff. And it's because you've decoupled your classes from each other, and you can just pass in these stubs, and it all works beautifully. And the best thing about it is it's really, really fast. So I'm just going to. We don't have that many unit tests converted to PHP unit yet in core, but. I'm just going to run them there anyway. It's like 165 tests, and it took 2 seconds. And if you're familiar with using simple test, and you know how long a single web test takes to run, because it's like installing the whole system and everything, just because some procedural function somewhere is expecting a database to exist. And we don't need that for the vast majority of the code that we want to test. So PHP unit is awesome. Okay, I've put up a list of resources. basically, there's all kinds of further reading you can do, sort of general stuff about dependency injection, and then I've put links to Symfony-specific stuff, and then Drupal 8-specific documentation. And, oh yes, one other thing to mention, like, by far the best way to get really comfortable with this stuff is to help in the ongoing effort to convert Drupal to using all of this, because we're by no means completely there yet. And this would stand you in really good stead when it comes time to converting your own modules to Drupal 8. So come along to the sprint on Friday and help out. And now I'd like to open it up to questions. Oh yeah, anyone who has a question, you need to go and stand at the mic there, please.
Hello.
Hi.
Thank you for your awesome talk. Very informative. You're a great instructor. So this isn't necessarily related directly to dependency injection, but the topics you covered today, I feel like this is kind of like a really jaw-dropping kind of moment, even though this has been happening over the past months in the whole D8 build and everything. But how do you think this is going to affect the technical part of the Drupal community in terms of size? Or I was just thinking about it, listening and following along. So what do you think?
Do you mean in terms of the fact that we're moving towards more standard ways of doing things? And well, like, yeah, I mean, the hope is that developers who have been working on other PHP projects, or who are familiar at least with PHP but not with Drupal, won't be scared off, because we're getting rid of like these real special ways we have of doing things, and we're using sort of best practices and what the rest of the world is doing. So yeah, my hope is that it's going to have a very positive effect on the technical part of the community.
Thanks.
So this may be a dumb question, but it may not be. How does this affect like hooks? Are we replacing hooks with events, or are hooks still a concept we're going to be handling?
That is definitely not a dumb question. Some hooks have been replaced with events. And there is, in fact, an issue ongoing that CHX is working on, which would basically support, it would basically, I think, support leaving hooks in place, but essentially have them fire as events. I haven't been following it too closely, but I mean, the simple answer is no, hooks haven't gone away yet, not by a long shot. But certainly some things have been converted to events.
As a follow-up question,
Sure.
How does one know, other than strapping your boots on and jumping into it, what's a hook and what actually needs to be sort of more object-oriented? Like, when do you pick one versus another in the new paradigm?
Well, everything should be documented. So if
Sure.
the hook, look at api.drupal.org, and I haven't seen if this is the case, but like if something that has been a hook through Drupal 5, Drupal 6, Drupal 7, and so on, and then no longer exists in Drupal 8, I'm pretty sure there'll be a link to what the equivalent way of doing it is in Drupal 8. I think. I'm not totally certain.
Much appreciated. Thanks.
Oh yeah, go to drupal.org/list changes, and you'll see.
Thank you for that terrific talk. If you'll permit me, I wanted to make an announcement about something that's totally unrelated.
Sure.
I just came from a FEMA conference call where they are talking about emergency disaster response to the Oklahoma tornado. And so a bunch of people are trying to organize a code sprint tonight, starting at 7:30 at Coders Lounge, where we're going to work on building some apps that would really help FEMA's disaster response for the tornado victims in Oklahoma. So anyone who's interested, 7:30 tonight, Coders Lounge.
Okay, thanks, Brian.
Hi, this isn't really about dependency injection, and it's a really basic level question, so hope it's okay. But you mentioned, like, with our modules, if we wanted to hook into this, and you actually gave the path name where our where we would put our information. So I don't know if you're able to get back to that slide or not. But the pathing that you gave was something like my module slash something, and then anything slash Drupal, then slash my module, and then so
Yeah.
my module slash live slash Drupal slash my module bundle.php. So my question is, once we're within my module, I mean, I can understand like why if you want live slash Drupal, but then why do we put my module again after that?
Okay, so there's a huge, big debate raging in a particular issue somewhere on Drupal.org about that very question. You know, this is the way our namespaces are registered currently. So we have an autoloader, and we basically tell it about these particular namespaces. So for each module that's enabled, it knows about the lib Drupal / my module namespace. So when it finds a class that's within that namespace, it knows what directory it's in. Get involved in the big raging debate. I don't really, you know, I can't really say any more about it.
Okay.
How would how would you deal with cross-service dependency? You know, service A says I need service B, and service B says I need service A.
That's just a bad design. Well, I mean, there are ways. No,
No,
I mean,
it's
there
not.
are ways of sometimes there, you know, circular dependency like just happens to be necessary, and there are various ways around that, like using proxies and this kind of thing. But I don't think there's anything specific in the dependency injection container that knows how to. In fact, I'm pretty sure you can't have circular dependencies in the dependency injection container.
I have been doing some page conversions yesterday during the code sprint.
Great.
I have been using like a lot of controller classes, and there are so many of them. How do you decide which one is the correct one to use for the router conversion? Because there's so many of them. Another question is, why do we use dependency injection through the Symfony component? And the third question is, what the services.yaml file in the plugins do for the module?
So the first question about controller, which controller to?
So it's just like, for example, user_page, converting that hook menu to the new router for the Drupal 8. And then we have been using like a lot of controller classes like Drupal core, and then controller and bunch of the classes name. I don't know, I've been told like just to follow the example and do the conversion because I'm trying to learn.
Okay, well, I'm sorry that you were told just to follow the example, and I'm also sorry that I don't know the actual answer to that question. I haven't been involved in these conversions. The best person to talk to is probably Larry Garfield, and ask him. And don't accept being fobbed off and told to follow the instructions. Sorry, what was the second question? Why are we using?
Second question is, are we still using dependency, or I don't know about that, but do we use the dependency injection through the Symfony component?
Yeah, we use Symfony's dependency injection component, and so it provides the classes, like it provides the container class, and you know, in certain cases we're probably overriding some of the Symfony stuff by subclassing it, but it's the Symfony dependency injection component that's powering all of this.
Okay, and third question is, what services YAML file in the plugin directory do for the module?
What is the services YAML file?
Yeah.
So that's where you actually define the services. So each service has an ID, and you specify which class, which like actual concrete implementation. You know, you specify the class to instantiate for that particular service.
Thank you.
Okay.
So this is related to the question about the screen you went back to. Suppose I'm writing a module and I want to you know, take some existing JavaScript library or some existing PHP library and provide a wrapper for it with my module. Wouldn't I then put files under my module lib and then vendor and then whatever library I'm importing?
That's a very good question. I'm not actually sure what what you're supposed to do in that case, whether it's a vendor. It probably is a vendor directory that you need. I don't know. Mark, do you want to speak to that? And there's a talk about Composer, right? I don't know if that's happened yet, but Rob Loach and Larry Garfield are going to be talking about Composer.
Okay, but I guess what I'm trying to get at is another answer to the question that was asked earlier. And I think the idea is that you're supposed to ignore the my module part, and lib/Drupal is the same whether it's in my module or your module, and there can be other things inside it, like lib vendor. Am I right?
Another way of thinking of it, like lib is not part of the namespace. Everything after lib, don't think of it as the directory structure, think of it as the PHP namespace, because that's what it is. It just happens that that maps one-to-one to directories, right? So it's just that we decided that the namespace needs to start with Drupal and then your module. And then after that, it's just your classes. So you wouldn't actually put other stuff in your lib, because that stuff would be yours.
Okay, thank you.
You mentioned controller resolvers, and I'm sorry, but I kind of went, my eyes glazed over because all I could hear was struts. So, but I didn't see an example of one. Did you show one?
I didn't show a controller resolver. There is one
Okay.
controller resolver. Like the controller resolver is just responsible for finding the controller for that particular route.
Okay.
But I didn't show an example of a controller either. But I pointed to, if you look at book module in core,
Okay.
that's a really good example of how that gets wired
Okay.
into the
It's
container.
not like struts, though, right?
Sorry?
It's not like struts, though, right?
I have no idea.
Okay. I hope not. Don't go look at struts.
Okay. Okay, I think that's everything. Thanks very much.